All right, we are live and we're getting started. So, as I was saying, quick, very, very quick mic check. Always like to do a mic check, although, one sec. There we go. Always like to do a mic check because, well, I had an experience once where I was speaking for about 15 minutes until I just glanced at the chat and everyone was screaming that they can see me speak, but they cannot hear me. So let me know in the chat if you have any problems hearing me. And of course, again, do log into the chat because otherwise I'm not seeing anything. I'm just seeing anonymous users. All right, so let's get started. We have a lot of ground to cover, and this is one of the I have a number of webinars and a number of topics that I like to do a deep dive into. This is probably one of my favorites, so I'm excited to get into this one. All right, so let's get right into it. Sharing my screen here. Perfect. All right, so what we're going to be talking about here is HateOS, right? We're going to start with what HateOS is. We're going to explain the concepts. We're going to basically dive into some of the theoretical parts of HateOS. And very naturally, we're going to start looking at an actual implementation as well. Very quick notes about me. My name is Eugene. I'm sure you already know you're on Bildung.com right now. So I run Bildung.com along, well, when I built this slide, I had the singular I run. There's a big team behind the site now. So I should probably switch this to we run because the team is almost 180 authors, 10 editors, and a number of other people. So I certainly don't run it myself alone. I build APIs for a living. Of course, that's a simplification of the work, but that's a good simplification if there ever was one. And some of these APIs, really just some of them, right? The recent ones, not in the early days, they get hypermedia and HateOS right. So that's enough about me. Now the goal here, right? What's the goal that we have with this presentation, with this discussion? Well, the goal is to first of all understand what hypermedia is and why it's actually very important to your API implementation. And then, of course, what is a good way to implement that with Spring? And while the practical nature of it and the Spring parts are certainly important, really where I see most teams and most developers struggle with hypermedia, and let's be clear here, most everybody struggles with hypermedia, right? But where I see that happening isn't really the implementation. Again, implementation is important. It's good to know how to do it right, but that's not where people struggle, right? Where people struggle is, first of all, even understanding what the heck hypermedia is and HateOS is, and second of all, why would it be useful for their particular API, right? That's kind of where people struggle. Once they get that, once they really see some good examples and figure out, oh yeah, that's how I can use this, that's how I can benefit from it, well, the implementation kind of falls into place. So what's on the agenda? First of all, we're going to talk about what HateOS is, right? Just introducing the concept. We're going to talk about JSON, of course, and we're going to talk about hypermedia, and more specifically, how JSON kind of corresponds to hypermedia. Is JSON a hypermedia type or not? And we're going to talk about that. We're going to talk about making the client simpler, right? Making it simpler by making it discoverable. And, that's kind of the first advantage here. And then we're going to talk about, how to do it, how to implement HateOS, how to leverage Spring, and how to leverage Jackson to do some very cool, more advanced things. So first of all, what is HateOS? And by the way, I pronounce it HateOS. I've heard it pronounced in other ways as well. I just personally gravitate towards HateOS. You don't have to pronounce it like that. And this is an acronym. There's no standard pronunciation here. So this stands for Hypermedia is the engine of application state, which, is not the greatest of acronyms, but it's certainly, it sends a message here, right? Hypermedia is the engine of application state. So this is basically the idea that you are going to drive the client, you're going to drive the client of your API through state changes in your system, right? So you're going to basically, force, or let's say suggest, the way that the client should interact with your API by modeling that interaction with state changes. So that's a mouthful. That's a complex thing to understand. It's going to get more practical very soon, right? As soon as we get into actual examples and into actual real world things, you're going to start kind of figuring out, oh, this is what that means. But before that, let's take a quick break. Let's just take a quick. All right, perfect. So sound is okay. Great. All right, that's all I wanted to check. Let's jump right back into the content here. Just wanted to have a quick look and see if the sound is fine. All right. So keeping with the HateOS discussion, right? The theory here should be that an API should have no out-of-band information. Out-of-band information is just a fancy word for documentation, right? So the theory says that the API should need no documentation. Now that's the theory, right? That's a good theory. That's that's coming right out of the doctoral dissertation of Roy Fielding, right, where all of these concepts were introduced, right, where REST itself was defined, and that's a great theory, right? But the reality is that we are not yet there, right? As an ecosystem, as a standards body, this is not yet there, right? This is not yet realistic. And because this is not yet realistic, a lot of people in the early days would, just say that, look, this is just not possible, and would think that HateOS would kind of lose its importance. Well, that's actually not the case. While this is not practical to do, really no out-of-band information for an API, while it's not practical, right, there is still a lot to get from HateOS. HateOS, at the end of the day, it's a practical implementation that helps the client. It's not necessarily just the fact that you're gonna, no longer have to document the API. So that's, right now we live in a world where, Swagger and RAML and a lot of other, options exist for documentation. Most of them get generated or they're automated in some way, or, for example, Swagger, that has deep integration with Spring, right? So we no longer worry too much about the documentation side of things. But the principle, right, the principle of not having out-of-band information, again, not very practical, but still important to understand in theory, because that's going to still inform a lot of the choices we make, right? So let's talk about the practice, right? So in practice, again, we're not yet there, right? Just in terms of standardization and in terms of adoption, this is not where the browsers are. For example, the browsers are there, right? HTML needs no documentation because it's a standard and because it's the only standard. That's super important, right? HTML is the only standard, really relevant in terms of, browsers basically only work with that. There's no competing standard to HTML, which is not the case in this area here. All right, so just to get this out of the way, I've heard and I've talked and I kind of debated a lot of these, discussions about, what is RESTful, what is not. At the end of the day, this is not constructive, right? This is not an all or nothing type of proposition, and at the end of the day, our goal is to build practical, useful, real world systems, right? It's not to build an academic paper, right? So we do have to be, mindful of what REST is. And we do, whenever we make, whenever we deviate from what the pure REST, implementation, let's say, would be, whenever we do that, we do need to know why we're doing that and what we're, potentially losing. That's still quite important. But that's something that, it's not a good idea to not know what that is. It's important to know. But that doesn't mean that we do need to be mindful of what we are actually trying to achieve. And that's building something useful, right? So, yeah. Now let's talk about an example. Let's actually finally look at an example. How do we buy a book from Amazon? How do we do that? Well, let's say we look at the process, right? We first, can find the ISBN of that book, right? Let's say the ID of that book. We go to Amazon, to the Amazon documentation, right? We find the book URL pattern, right? We use the ISBN with that pattern and we get back the URL of that particular book. We then do a get on that URL, right? We get back the book JSON. We then go back to the documentation, right? We have to look up how to purchase, right? How to add the book to the cart. We figure that out, right? From the documentation. We do a post, we trigger that process, that operation. We add the book to the cart, right? When we go back to the documentation, of course, because then we have to figure out the next step, right? The buy operation, now that the book is in the cart, right? So is that what we do to buy a book? I mean, that would be insane, right? If we had to do that, we would never buy a book. I mean, that would be ridiculous. That's that's kind of what that would be like. I don't know. Hopefully this is hopefully this is coming out and the video is working, because I really like this animated GIF, but that would be ridiculous. So that's not what we do, right? That's clearly not the process of buying a book, right? This is not how we use the web, right? So what we do here when we buy a book is we use hypermedia, right? That's basically what we do when we buy a book. We navigate to the book page, we click on a link, right, to add the book to the cart. That's how we trigger the operation. We don't go to the documentation. We don't, figure out how to do it. We don't do a post. We just add, we just click a link, right, or a button. That's all we do. And then we click another link to purchase, right? I mean, obviously this is slightly simplified. There's a payment process in there as well. Maybe not, because Amazon actually has everything you need. You may even be simple. It may even be simpler. You may just do one click, right? But again, at the end of the day, that's what you do. That is how you buy a book. So what's different here? Why is this process so much simpler? What's the main thing, right? What's the common thread here? Is the link. That's the common thread. That's the tool that we use now to buy a book and to make that book purchasing process a lot simpler, right? I mean, significantly simpler. So that's the link. So simply put, now that you've seen an example, right, and you've seen like what it would be like without links and going to the documentation, what it basically some APIs kind of ask their clients to really do. That's really how some APIs, that's how you need to interact with them. You need to go to their documentation, figure out the operations, try things out against the API. It's a whole mess, right? And that's what hypermedia tries to solve. A very simplified statement here is that hypermedia means including links in your responses, right? So whenever your API is sending back resources, right, you're going to also send back links. That's the core of it. So with that in mind, the hypermedia types are media types that have support for links, right? In a nutshell, That's what a hypermedia type is. It's a hypermedia type is a media type that actually has native support for a link element, right? Now, with that in mind, right, what would be a hypermedia type? Well, let's first of all, let's actually, before getting into that, what would be a hypermedia type? Well, HTML would be a hypermedia type, obviously, right? Because it has support for links. What would not be a hypermedia type? For example, JSON. JSON has no semantic for the link, right? There's no linking semantics in raw JSON. Now, there are, of course, multiple attempts to add linking semantics to JSON, and we're going to talk about those, but raw JSON has no link support. What does that mean? Well, it means that any API that simply outputs JSON, like raw JSON, no other extra layer, basically does not and cannot support hypermedia because JSON has no concept of a link. So that's certainly a good place to start, a good place to start understanding all of this. Now, how does all of that help the client, right? Because at the end of the day, what we're trying to do here is we're trying to build an API that helps the client, right? That makes things easier for the client. And, a major advantage of having links and providing these links back to the client is when you're talking about third-party clients, right? Because, if you're working in an enterprise environment where, everything is internal and, you're building your API, but you're also building, the client of that API, well, then things are a lot easier, right? There are still certainly advantages in that environment as well. And we're going to talk about those. But if you are building an API that is going to be used by a third-party client, right? That you're building, this API and then exposing it, and it's just going to be hit by other, consumers from outside your organization that have no idea what's going on in your API, right? Well, that's where this type of hypermedia support is critical, because all of a sudden, they're gonna do an integration, right? Generally, when this happens, a developer will do an integration with your API. Well, that's gonna be a lot easier to do if your API supports hypermedia and guides that implementation and guides that developer through exactly how to interact with the API. It's not going to be as easy if they have to, do that process that we talked about earlier. Go to the documentation, figure out a bit of interaction, try it out, go back. Like all of that process, that takes a lot of energy. That takes a lot of effort. That makes an integration, difficult. So that's a important advantage. It's not the main advantage, but it's an important advantage, especially if you have competition, right? Like, I've been in that case where, we were evaluating a number of solutions. I tried to integrate and to do a quick spike with most of those. And some of them were just much better than others. I mean, the API was cleaner, easier, simpler to do the integration with. And obviously we chose the ones that were simpler. I mean, that was basically all I was trying to do, was get a simple example working. And if that example, took me 2 hours rather than 3 days, great. That's the solution I went with. And that's basically how most developers will choose that if there are, if everything else is the same. All right. So that's one thing that you need to take into account. Now, the other important aspect here is that the client will start understanding those conventions, those hypermedia semantics, because you're going to expose a hypermedia type, and they're going to be able to navigate the system a lot easier, right? And all of the business logic that they had to kind of encode, like whenever you interact with an API, you encode a lot of that interaction in the client, right? A lot of that in the, like go here, send this kind of data, get back, go there, like all of that gets, basically encoded or added as logic, as actual logic in the client side, right? Well, the problem with that is when something changes, right, that breaks, that no longer, that has to be updated and maintained. Well, now most of that, not all of it, but most of that logic will go on the server where it belongs, where it should be, on the server side, and the client just adapts to it. So what happens is, and this is the main advantage, the client will be a lot easier. It will evolve and adapt to changes on the server side a lot easier. So what it means is whenever you update the API, whenever you change something, making that change a non-breaking change is a lot easier, is a hell of a lot easier than when you have like a number of hard-coded clients, like literally restricting you from making any changes. So that's where this starts coming in handy, especially with third-party clients, right? Where you basically you have no control over what's going on there, right? They're clients that interact with your API, but you're not writing them. Well, in those cases, it's gold basically to have the option to make changes to the API, to really evolve the API without breaking clients. That's a critical thing. So that's where this all starts, making sense and being handy. So, that's basically this slide here, right? The fact that we can evolve it a lot easier without breaking clients. All right, so let's take a quick break here. And let's see if there's anything that I need to be aware of in the chat. No, looks good. All right, cool. If you have questions, don't hesitate to leave them here. I'm going to make just quick breaks from time to time. So definitely leave your questions right there. All right, let's go back. All right, so finally here, again, the first run experience for integrations, we talked about that, like, developers, basically having just a much easier time integrating with your API. And that can certainly be a competitive advantage, when you kind of can provide that kind of simple experience, right? The first run experience, that's critical. A lot of developers will, if it's just too complicated and if there are alternatives in the market, they're going to give up. They're going to go somewhere else. I certainly would give up if the first run experience would be, I would have to do a lot of work. So the less work they have to do to get value and to have like a good integration with a simple API, the better it is. All right. So I had to sneak this slide in there because I think by this point, whenever I talk about this, by this point, if you don't have experience with HateOS, you're kind of looking suspicious, right? You're kind of like, okay, is that, how is that really going to work? And you're gonna see some of that when we go into implementation, right? Now, it's important to understand, and I generally want to add this as a caveat here, is that, this is not just about adding hypermedia to your API. If that is all you do and the client doesn't adapt and doesn't use that information, well, then it's kind of useless, right? You can do a lot without the client side as well, right? If you control the client, if you're writing the client, then great. That's absolutely the best. That's the simplest scenario, but it's, you have full control over what happens there. But even if you don't control the client, it's important to, give guidance to other developers doing implementations against your API, right? If your API is consumed by third-party, clients, it's important to guide those implementations and to explain what the hypermedia information is useful for, how it can be used, how it should be used, and what because the thing is, right, when these clients use the implementation, then you can then you can make changes, then you can evolve your API without breaking those clients. So that's why it's important to give that kind of guidance. Now, this is not very I mean, there are scenarios where this fits, but generally speaking, this doesn't fit for public pixel perfect UI styles of UI. Like, if you're building some UI that is public facing and it's not an application, it's more of a site, right? That becomes a little bit more tricky to change things. So there are ways to do it. For example, these predefined dynamic areas of work. For example, Amazon does that, right? Amazon does that a lot. Like, a lot of the areas of the site are pre-populated. Like, for example, the recommendation area, right? That's a separate predefined area that even though it's on a public site in a UI, there's a very clearly delimited area that gets populated with products. So that's one technique to do it, and it's it's important to kind of understand how to do that. But now let's talk about like the kind of the adoption here, right? Like, is this really used? Well, let's have a look, right? This is kind of what adoption looked like. Well, this was last year or even 2 years ago, but I mean, this is kind of what this is, right? This is the growth and the adoption of HateOS, right? It's basically kind of a hockey stick here, right? So this is pretty interesting to see, because it's the kind of it's basically the kind of visual representation to show you just how useful this is, right? How well it's getting adopted. All right. So now, with all of that in mind, let's start adding some links. So where do we add those links, right? Well, we have to add those links to a hypermedia type, right? As we talked about, hypermedia is a requirement here, right? In order to be able to add those links, we need a hypermedia type. Well, is HTML, for example, a hypermedia type? We said from the start, yes, it is. It has linking semantics, right? It has the A element, which is a link, right? So that's good. That it has the link primitive. XML, on the other hand, has no concept of a link, right? So in XML, you're not going to find any semantics for linking. Neither are you going to find those in JSON, right? At least, as we talked about, not by itself. And so, how can we add those semantics, right? Because JSON is still really, really useful, right? We want to use JSON and we want to keep using JSON, but how do we move from raw JSON to JSON plus linking, right? How do we make a JSON hypermedia type, right? Well, it turns out that we're not the only ones trying to do that. There are a lot of implementations, a lot of proposals, a lot of activity in this area, right? HAL, the hypertext application language, that's one of them, but so is collection plus JSON. So is Siren. Siren actually goes goes further than just adding links and adds actions as well, which is actually quite useful. There's JSON LD, right? This is JSON for linked data, which the main selling point of JSON LD is also very powerful, is the fact that you can add JSON LD to your project without breaking changes. Like it's an additive type of media type. Like if you're using JSON, you can transition from JSON to JSON LD without making any breaking changes to your clients and to your kind of responses, right? So that's pretty useful. And there are a number of others. I mean, you have JSON API. That's one of my favorites. That's a spec that's very, it makes some great choices, and it's very intentional about what it tries to do. That's a spec worth looking into. And by the way, the spec itself is quite readable, right? I mean, as opposed to other specs, this one you can actually read through it with ease. So that's one of them. But the point is there are many others. We're not done, and we're not close to being done here. There's one called Uber. There's one called Mason, which I have not used. There's one called Yahapi, which also I have not used. There's CPHL, which again, the point is there are many media types that try to add these hypermedia semantics on top of JSON, right? So we're gonna stick with HAL, right? That is the one that Spring adopted first, right? Even though now kind of there's support and there are discussions around adding more. HAL is kind of the reference in our space, right? So that's it's certainly not necessarily the most adopted. It's just what the Spring team chose, right? So something to keep in mind. And let's actually do that, right? Let's let's do better than the raw JSON here, right? Let's not just use application JSON, right? So we're gonna stop using the raw JSON, and we're gonna start using HAL, right? So that means application / HAL plus JSON. So that's the media type, right? And what we're going to do here is we're going to drive our implementation with Spring HateOS. Spring HateOS is the library that we're going to use, and we're going to start simple and then kind of move our way into more interesting and advanced scenarios. So that's basically what we're going to do now. But until that point, let's see what questions we have. All right. So Sanjay asks, is REST and HateOS sufficient for all APIs? Do we ever need GraphQL? Well, that's a great question. The thing about sufficient is, it really depends on what you're trying to do, right? I mean, I would say, yeah, there's definitely a place for GraphQL. There's also the debate of like, is GraphQL really fully adherent to REST or not? But you cannot, again, that's a let's say an academical argument. The real argument is that it's useful. So yeah, I mean, I personally like the solution. I'm not really using it on client engagements a lot. I usually do REST and HateOS, and that's more than enough. But again, it's certainly an option. And yeah, I'm not saying it's redundant, because it's not. All right, so let's see. Andres is asking, is HateOS, let me read this one, most difficult to create? Right, okay, so the gist of it is, does HateOS make the client implementation more difficult? Yes, it does. Now, how much more difficult? I mean, not that much. Realistically, what you have to do is you have to, as a client implementation, you have to, be able to kind of understand those links and, how to interpret them, which is not that difficult. I mean, it's something that it's a bit of convention and it's a bit of parsing, and it's not that difficult. Like and again, the advantage that you get as a client project, because yes, of course, there's extra work to be done, but the advantages are significant because remember, if you're a client that, works with an API that keeps changing, you're going to have to keep changing the client, right? Whenever the API changes, it's even inside an organization. Usually the team working on the client, is not the same team working on the API. So if the API team keeps working on the API, the client needs to be kept in sync. And that's a lot of work. That's a lot of changes. That's a lot of extra, stuff that they have to do. Well, with the work of integrating HateOS into the client, right, which is again real work, then you have to do a lot less of that. You still, of course, have to adapt the client, but just a lot less. A lot more changes become a non-issue, right? They're basically just going to be smaller adjustments that the client doesn't even have to worry about. So that's kind of, that's where teams get, convinced to do that. Like that's kind of the one of the major decisions of, oh yeah, I get this part for free. So that's why I'm going to spend the time to implement this kind of thing, because I get it for free in the future, right? So yeah, that's a good question, and yeah, the answer is certainly yes. All right, so let's get back, and now let's jump into the implementation. So Spring HateOS is going to very simplified, statement here, but it's essentially helping us adding links into our responses here. So that's kind of the main functionality. It's going to use HAL, as as I was just saying. We're gonna add this in by using this Maven dependency, just using Spring HateOS. Obviously assuming in this case that there's in this other example we're using boot and this has a starter. So either way, right, either like this without boot or like this with boot, and that's basically the only dependency you need to add. And now let's look at some actual example. So let's say we have this resource, right, in an old project, right, where this didn't have any sort of HateOS, support. So let's now say that you want to add Spring HateOS and you want to add this new support. Well, in this particular case, what you do here is you extend resource support. That's a base class that comes out of Spring HateOS, and that's pretty much, there's going to be a bit more, but that's pretty much all you have to do to make your resource, right, Spring HateOS enabled. So what does that mean? Well, it basically means that the changes are minimal. Like I've migrated entire APIs, and these were hefty 60, 70, 80 endpoint APIs to have HateOS support in maybe a couple of days, because the framework helps you and it's pretty simple, right? So for example, Spring Data REST is a lot more complex, a lot more heavy. Spring HateOS, on the other hand, is not that heavy, right? It's actually relatively relatively simple, right? Relatively easy to implement. So let's give this have a look here, right? So what if we don't want to do this with the fields, right? If we just want to wrap our old resource. Well, we could do that, right? So Spring HOS is smart enough that it actually allows us to wrap our previous resources and just do that. Just do a getter, a set, a getter, the constructor, and there you go. That's all you need. You can even go one step further here, and you can do that. So that, you'll notice that we're now extending, the resource class, which is another, utility based class out of the framework. So you don't even have to provide the getter. You basically can wrap your old resources into HOS enabled resources without changing anything. Just changing the response type on the controller and just providing this kind of resource. So super simple, super to the point, right? Now, this is what the controller would look like. So this is a typical controller, of course, slightly simplified, not very simplified, right? Because usually you don't have, a lot of logic in controllers anyway. So there you go. That's all you need to do to change the old controller, right? Which, presumably was returning the book, to now, return back to the client the book resource, this new HOS enabled resource. That's all you need to do here. So you see the migration, adding this stuff into your API is actually very simple. So that's one of the big advantages of Spring HOS, is that it's just simple. Now this was the simple book that had no links, right? This is before Spring HOS, before anything. This was like a simple example of a JSON, right? Now, it's a good idea to include a canonical URL into any resource, right? So any resource should have a canonical URL, and we can talk about why that is. But the general gist of it is that resource, right, may be accessible on multiple paths. So it may be accessible as a child of another resource or whatever it is. So that's why a canonical URL is always useful. Like, look, this is a child of some other resource, but if you want to access this individual resource by itself, this is how you do it. And that's what the canonical URL does. So when you want to add that, right, this is how you add the self URL, the canonical URL. This is how you add that with Spring HOS. So you see the API is actually very simple, very clean, very straightforward. That's all you have to do, and you've added the canonical URL. Now, of course, we don't want to do that. We do want to do that, but we want to improve it. We don't want to hard code our URL like that, right? I mean, that doesn't look right. If you have like local host hard coded like that, I mean, it's not going to be okay, because obviously, this is not going to just be deployed on local host, right? So you want to change that. So here's how you change that. This is basically how you make it relative. So you have the link to the current mapping, and Spring HOS has a deep integration with Spring, right, and with Spring MVC. So that's how it knows how to do that. And then you do books, ISBN, right? So okay, that looks fine, but I still think we can improve it. So instead of manually building these URIs technically, right? Let's point to the actual controller, because again, the nice thing here is that this is a Spring project. Because of that, the integration with the other parts of the Spring ecosystem are pretty deep. They run pretty deep, right? So for example, we can point to a controller method, and so the framework will figure out the URL. The framework will go through the handlers, will figure out, okay, this is the right one. Like it will know how to do that without us being like, oh, here's the URL, right? So that's pretty cool. It's a deep integration because it's kind of the same ecosystem, right? So we don't have to now duplicate our mappings, right? Remember, the operation already is mapped. It's already mapped, it's already available. We shouldn't have to specify a hard-coded URL like that, right? So this is how you do that. You can link to the controller and you can now, benefit from the mapping that knows it's mapping. It doesn't need to, you don't need to specify it. You can just link to the controller. So that's much better, right? That's starting to look clean and nice and flexible, right? But I still don't quite like it. I still find the second part, the slash part, unnecessary. So instead of doing that, instead of doing this slash part, because again, the slash part here, that's still providing the mapping. Instead of reading the mapping from, the one we have, we're still providing it here. So there you go. That's how you do it. You can actually now link directly to a method. That's pretty cool and that's pretty powerful. Now you can actually link to the method directly, and whenever the mapping changes, this link will adapt. So there you go. That's how you can build a better self link or canonical link. Now this is what this looks like now. So you see the old JSON is still there, right? But now we get this link element, and we get these links here that are basically just an array. So we can keep doing that. We can keep adding links, and this is an example of a by link here, and we can we're going to add this link. This is no longer just a self link. This is an actual action, right? And this is how it looks, right? So you basically get a bit more semantics, a bit more guidance here. So that's basically what this is starting to look like. That's how you can start building links into your responses, right? Into your API. All right. So now let's take a quick break. See if we have find by ISBN does not have a response status. Well, keep in mind, response status is optional. You don't have to specify that. It's going to be a 200 OK if you don't specify it, right? So keep that in mind. All right. So let's see this ourselves. So let's now go through that earlier example and let's buy a book. So we start at the root of the API, right? We do a get. Right? Well, in this case, we're going to go with JSON. Obviously, this should be HAL plus JSON, but JSON is a okay fallback for the accept header. You get back the links here, and you see, oh, I see that I can access /books. Okay, perfect. Let's go to /books, right? We're going to get back the list of books. Well, obviously, in our case here, just one, right? We see the self link, right? The canonical link. We access that. Again, all we are doing here is we're navigating based on the links that we see, right? We're not doing anything, we're not going to the documentation. We're not, looking at Swagger. We're just navigating and choosing our next operation based on what we see here, what on the link, right? So we do a get here, we get back, the book plus the clear next step, which is the buy operation, and we see clearly that this has to be done on this URL here, right, on the cart URL. So clearly we need to add this book to the cart, and that's the URL. So we're gonna do a post, right? As the typical creation. we're going to do a post. We're going to post and add this to the cart, right? The book, the ISBN, and the title. We're not going to send back the links, right? The links are just for us. We don't have to send them back. And now this is what we get back. So, okay, we get back the fact that this is good, right? We have the book in the cart. But now, how do we purchase? Well, notice the purchased flag here, right? The purchase flag is false. So how do we purchase? Well, we are going to set this flag to true. That's triggering, right, the state change of purchasing. Well, the good thing about that, obviously, this is slightly simplified, right? We're kind of skipping over the actual payment. But the point here isn't really to kind of look at the payment process. So how do we do that? Well, the problem with that is there's no clear operation for changing a flag, right? The flag, there's no clear like standard operation to change a flag from one state to another. But remember, we're dealing with resources here. And if you take a look back in here, this is the cogged. This is our cogged resource. So because of that, we're simply going to mutate, right? Update basically our cogged resource. That's all we're going to do. And the server will see that operation and will probably, start again a payment process. But the point here is not going to just update. It's going to start triggering an entire process. But from the client point of view, this is simply, an update. So all we're going to do here is we're going to do this with a patch, right? We can do this with other verbs, for example, a put, but a patch will be nicer because the patch allows us to send a partial update, right? So you see here, we're not sending too much. We're just sending the purchased flag itself. So that's pretty cool and pretty, if you've not seen patch before, this is how it looks like. And this is just how powerful it is. You can do it, just by sending the diff, basically, right? And there we go. We're done. Purchased is now true. And, we've purchased the book. Now, all throughout this process, we have never even looked at documentation. We have never even, opened anything. We've just followed the API. That's basically HateOS. That's the API guiding our flow. So this is kind of a start to finish example here. And unfortunately, my voice is also, I'm getting over a nasty cold, and my voice is starting to crack. So luckily, we're also almost at the end here. So I'm going to try to go a little bit quicker than I would like to, just because my voice is starting to crack. All right, so very quickly here, and by the way, the slides are going to be available, and that's where you can, and obviously you can follow up with questions over email. I mean, I'm always up for questions, so feel free to ping me, and happy to have a look. Now, our book implementation is very simple, right? However, a real book implementation will have a lot of fields, a surprisingly large amount of fields. So, if you use like /books and retrieve a list of books, that's a huge amount of data. We don't want to send all of that data over the wire. So when we get the list, not a single resource, a full list of resources, we should get a lot less data. A good way to do that is using the view. So, you can basically define a view, and in this case, it's a summary view, and then you you annotate your fields, right, in your resource with that summary view. And you say, look, this is part of the summary view. So most stuff, right, most fields should not be part of the summary view. So when you then, return the list of data, then you activate the summary view. And so the data is just going to be the summary. So for example, this would be a full JSON, and this would be the lighter JSON. So notice here you have ISBN, author, and title, right? And now you're only getting the summary, which would be, ISBN and title. Obviously, this is not that different, but when you're dealing with like 100 fields, this is a lot different. So worth doing, clearly worth doing. Now, if you need more control than that, if you need more fine-grained control, and when you get a book right now, right, you get this predefined representation. But what about if you want to pick the fields? What about if you want to specify exactly, I want this field, and I want this field, and I want this field, and that's it? What about that? Because that's going to give the client all the tools, right? That would be the ideal way to do it. For example, this would be a request. I want the books, this particular book, but I just want the title field. I don't want everything. I just want the title. Well, this is how you do that. This is a more advanced functionality. So this is the filter, the JSON filter functionality, which again is a bit more advanced, but it's also super powerful. So you need to basically define this filter provider. And after you define this provider, you kind of need to, unfortunately, return a Jackson specific, class here. So that's the only downside here. But again, for the power you're getting, for the flexibility you're getting, this is a minor thing. You have to return the wrapper, the Jackson wrapper. And when you do that, now you can do something like this. You can do a get, and you can say, give me this book, but don't give me the whole thing, just give me the title. So you can imagine just how powerful that is, giving your client the ability to select exactly what fields they need. Because most UIs will only display a handful of fields, and so that's basically a lot less data over the wire if you give your client the ability to do that. So that's, again, pretty powerful. We're only going to look very quickly at another advanced scenario that's, actually, we're not even going to look at it. We're just going to kind of mention it, because this is, like HAL has support for embedded resources. That's pretty powerful if you need that. Then let's see. Yeah, basically, we're not going to spend too much time on the embedded resources stuff, because, well, first of all, because it's too advanced, but second of all, it's also the kind of thing that you can that's more of an implementation detail, right? So that's why we're kind of speeding past that part. But there we go. We are done, and we're not even that late. Oh, that's cool. That is cool. All right, so let's see what questions we have here. Where do these methods come from? The link to instance and the method, right? So that's just HateOS, Spring HateOS support. So that's basically the core API of Spring HateOS. So that's where they come from. Probably better to say you are passing a representation, not a resource. Sure, technically, yeah, you're passing a representation, right? I mean, the reason I keep referring to resources is, when you're thinking of like what exactly your API is exposing, right? Conceptually, it's exposing resources. Technically, yeah, it's definitely it's exposing representations of those resources, obviously according to whatever media type you're capable of producing, and according to whatever media type the client is asking for, right? So the intersection of those two. Is it possible to combine Spring HitOS and GraphQL? Hmm. That's an interesting question. I've never tried to do that. Technically, I don't see any reason why that wouldn't be possible, but yeah, I'm not sure. I'll have to look at that, but feel free to send me an email with that question, and I'll look at it and I'll get back to you. I've never tried to mix those two together. Is there a path to teach Swagger CodeGen about Spring HitOS summary objects? Yeah, Swagger CodeGen is there's I'm not sure if there's any good way to do that, because Swagger CodeGen, is obviously is not gonna result in Spring HitOS enabled code. I mean, the only way to do that would be to actually, take the generated code and then just own that code. Like just do it as a starting point and then, modify it yourself. So yeah, that's kind of because there's no, as far as I'm aware, there's no direct support there. All right, and let's see. Some days back, I consumed the REST API with Hypermedia. At a certain point, it became a headache. My task was to fetch the metadata of tables. Right. One quick sec. Still reading this one. Okay. Well, that's not really. I mean, it's more a statement than a question, and I'm not really sure exactly what that API was. The gist of it was that the consumption of a HitOS enabled API turned out to be problematic. The thing is that can be for a variety of reasons, right? One reason could be simply that the implementation that you were consuming was not that good, right? Another reason might be that you were not using the right tools to leverage and make use of those links, right? I mean, yeah, that's it can certainly happen. I'll just say that, because without like more specific information, I mean, I have no idea why that was difficult to consume, but I imagine it's a combination of probably the implementation wasn't that good, but also probably you weren't using the tools that know how to consume that. All right, let's see. Can HateOS be disabled and enabled in a REST API? I mean, technically, yes, you can certainly do that, right? I mean, but you have to build that functionality yourself, Andre. Because remember, once you enable it, in terms of not enable it, because enable is not really the word here. Once you integrate it into your API, it's integrated. There's nothing you can like take it out. You can probably, I mean, not probably, you can certainly build functionality if you really need to integrate, to turn it on and off. You can certainly build some feature flag that's going to enable you to do that. But I mean, it's manual work. It's manual and it's not ideal, because once you have it, the client can certainly ignore it if they want to. Remember, you're not changing your representations, right? You're not changing, anything about those. You're adding information, which means, generally speaking, adding information is a non-breaking change, right? So, the client can simply ignore that and you don't have to turn it off. All right. looks like those were the questions. All right, cool. So thanks for joining live. This is definitely a fun topic and an important topic. The only reason I haven't enjoyed this one too much is just that my voice is is cracking, as you can probably hear on the call. But other than that, it's definitely been fun. And let's stop presenting here. All right, there we go. So yeah, my voice is not ideal today, but I announced these webinars so far in advance that I didn't want to cancel it. But yeah, I'm just running. I'm getting over a cold. All right, cool. Well, guys, again, thanks for joining me live, and yeah, feel free to send in questions if you have them about HateOS, about Spring, about REST. I mean, about pretty much anything in this ecosystem. And yeah, talk to you next time. Cheers, guys.